New in the space sector as well. I mean, we started in August 2013. I'm obliged to do this. We started our activities in 2011 and officially, rebranded ourselves as Hyperion Technologies in 2013. And we're with a small team of currently about 7 people. We're growing. And what do? We develop subsystems and components for small satellites, period. And that's a very broad definition, I know. I'll go in depth later. We also do some consulting on small satellites and missions, and I guess that's also one of our core competences as a resource provider. And of course, since everybody wants an off-the-shelf product, but then entirely different, we also adapt or do customer-specific developments of our components. And we also have some spin-out activities in other sectors. So what do we make? The title thing. We're most well known for our star trackers. We focus primarily at the moment on ADCS systems and related activities. And we have some data acquisition units. And what are we going to develop, or actually what are we developing as well? We're developing payload processors, essentially high performance computing in a very small form factor. Some transmitters and receivers, some antennas and antenna systems, and some payloads. If you're interested in any of it, drop by or drop me an email. And how do we do that? What sets us apart essentially from any other run-of-the-mill CubeSat company? We intend to develop high-performance, best-in-class systems. So you won't find the cheapest components with us. Sorry. If that was your interest, don't come to us. We can always debate, but at a certain point, quality comes at a cost. We want to make very reliable components. However, we tend to use COTS components, and those two are mutually exclusive if you ask anyone in the space sector. So we do have to, we also have access to rad-hard components, and we can even do ASIC design if need be, but we tend towards COTS components because they're just better, period. But of course we have to prove that. So we do all the basic tests, functional tests, obviously, thermal vacuum vibration tests. But what we also do is very extensive radiation test campaigns. So we know exactly how our components behave in a radiation environment. And we can also tell you, based on your orbit parameters, what the expected lifetime of the components will be. We usually add some safety margin for ourselves, but if we tell you it'll last for 10 years, it will last for 10 years. And that's pretty much, that's pretty special in the sector. So you get high performance systems, that's a given, look at the spec sheets, but they're also, reliable. It's high reliability, but that's relative depending on who you talk to. So they're robust, they're failure tolerant, they're as robust as professional systems, we'd like to say. But they perform a lot better. So, now the moment we've all been waiting for, the currently available systems. This is the one we're most well known for. This is our CubeSat compatible star tracker. It's the world's smallest star tracker. I, in fact, have it with me. It's too small to see, so drop by the booth. It's a fully standalone device. So this thing, with housing, I think it's 40 grams or something, contains everything. So you get quaternions, pitch, yaw, roll rate, slew rate out, and all you have to do is feed it power. How much power? Well, 600 milliwatts. That's the one thing physics doesn't help us with. You need some power to do some of this. We're one of the fastest star trackers on the market. We have an update rate of 5 Hertz. And the accuracy is, well, okay. It's not as bad as you would expect a small star tracker to be. It's about 30 arc seconds 3 sigma, which is on par with most normal star trackers. And you can buy it right now. I think we've sold about 17 or 19 units already. So it's going well. We have we had a very odd request. You know, somebody wanted these off-the-shelf star trackers, but then slightly different, for an application on an ISS mission. So we basically developed a completely new star tracker on the same principles. It's the ST400, twice the accuracy thanks to the much larger optics, slightly higher power consumption because it's RS-422 as a primary output, and it can handle a lot larger baffles, so you can also get a much better sun exclusion angle for this system. But as said, it's, well, massive. It works though. In the datasheet we specify 10 arc seconds RMS. This was somebody in Germany in the middle of winter freezing their, well, any appendages they had, they were frozen off at the end of the test. And we reach, with all of the delivered devices, 7 arc seconds RMS, so we actually very comfortably meet our specifications. And of course, since this was for an ISS mission, ISS does not talk any of the interfaces we provided. We had to do a data acquisition system. We have to convert the RS-422 signals to, again, RS-422 on the other side, but we also had to do power management, synchronous sampling of 6 bought-in fiber optic gyroscopes and 2 star trackers, whilst managing all of the temperatures. So we made a unit there, so if anyone's interested, it's a very nice, almost a kilogram block of metal. It's not with us anymore, unfortunately. It's up there. It didn't explode, so that's good. We're in the Russian segment. I think I can point at this. No, this way. So we're underneath the segment, so you can't see it in the picture. We're on one of these cameras. It's a very high resolution Earth imaging camera with, I think, 4K video capability and 20 megapixel imaging or something. Because this camera is mounted on a robotic arm which has to do the slewing to follow the targets. And yeah, here you see it mounted, and we are somewhere there. So we do have some space heritage. Unfortunately, it was decided to split the system into the fiber optic gyro system and the star tracker system, and the star trackers were not launched yet because the initial installment of this system, I think some of you might have read about it, failed. So they had to use the second EVA time slot to go and mount this system. Anyway, it's nice to know what your satellite's looking at, but it's even nicer if you can control it. So we made reaction wheels. We have different series. There's a 200 and 210 series, which are the very small ones on top, and the 400 series, which are larger. Essentially, it's very simple. The 200 series of any of our products is intended for 1 to 4 unit CubeSats. When pushed, it will work for a 6 unit, and the 400 series is actually intended for 6 to 12 unit CubeSats, or slightly above that. So the storage values and the torque values are actually matched. Here you can see some tests. This is of a 0.15, 200.15 series. So the step response, obviously it's not instantaneous. It has to spin up, that's also physics. And a rundown test. But it actually works quite well, and speed, it maintains its reference set speed, as you can see, very nicely, very neatly. Reaction wheels build up an imbalance, so they have to be offloaded every once in a while. So we made magnetorquers. We like to believe we have the most efficient magnetorquers on the market, thanks to some fancy tricks in the electronics. So yeah, we have a large series. Anyone interested, please pop by. What we can also do with these magnetorquers, and that's quite unique in these, is we have a boost mode. So essentially we have an optimum efficiency point, which is the one you buy it for, but you can boost it to various values. And also it's not simple bang-bang control. You can actually set a dipole moment. You can see that here, where we asked it to do a sine wave, and it can actually do a sine wave. But also, more interestingly, a 3-unit CubeSat can actually be detumbled from 35 degrees per second in less than 15 minutes, meaning that your satellite will be operational before you know it. We've combined everything into a fully integrated attitude control system. This is actually it has everything, even target tracking modes, meaning latitude, longitude coordinates are provided by the user, and the system itself will point one vector of the satellite towards the target. If the target is not in view, it won't point. It will keep pointing in whatever the previous command was until it comes across the horizon. Yeah, first FM unit scheduled to be launched in December 2013, 15 this year. Sorry. Yeah. Anyway, we have a larger version. We have larger wheels, larger magnetorquers. So obviously we made a larger integrated system. That one is almost ready. So provided I get back in one piece, I can do the final tests of the engineering models. It's larger, same features, but it has an additional high-performance IMU, which allows for longer sun blinding periods, because the baffle length in CubeSats you can get is rather limited. And what are we working on? Well, very simple. More is more better. So we essentially are making larger systems, because we see lots of requests for up to 50 kilogram CubeSats. I still wonder how they would ever make it happen, but anyway. So we're making the 600 series aimed at 12 to 24 unit CubeSats, and the 800 series aimed at larger. So that's us. If you have any questions, I have a booth. If you don't find me, there's cards, flyers. Pick it, take them with you, and don't take my demo material.